Dr. Ronan Connelly er en uafhængig forsker, som har lavet en række studier omkring klimaet. Her taler vi om et af hans studier, hvor han og en række medforfattere har kigget på, hvad der ville ske med klimaet, hvis vi fortsætter med at leve som nu. Samtidig taler vi om videnskaben er blevet lidt for specialiseret, så man i mindre grad forsøger at koble de mange videnskabelige felter sammen, som har indflydelse på klimaet. Velkommen indenfor.
Okay.
Dr. Ronan Connelly, thank you for joining me this morning.
Thank you for inviting me.
You published a number of scientific papers regarding to climate change and the climate system. But before we get into that, can you please introduce yourself? Like, who are you and your field of research?
Yes, I'm an independent scientist. I've been working as a scientist since college. I do a lot of multidisciplinary research, as in looking at multiple subjects together. From when I was in university, I kind of became concerned about the fact that a lot of science has become over-specialized, where there's a lot of pressure on you as a scientist that wants to get into research to become more and more focused about narrow topics so that you can be the expert in this tiny little niche. And I kind of, from my background, I was seeing that this was leading to a sort of a myopic view of topics where people would have an awareness of very important fields, of aspects of it, but they would be unaware of what's happening in the larger scientific field. So even during my undergraduate and my PhD and my postgraduate work, I was very interested in trying to develop expertise in multiple different subjects, and I've realized that when I started work after my PhD, I started a lot of work in environmentalism, which it turns out having that multidisciplinary focus is very suited to subjects like environmentalism and specifically climate change, which I've been researching actively since I think around 2009. I have, if anyone's interested in finding out a bit more about the details of my background, I have my personal website, ronanconnellyscience.com, has a bit of autobiography there.
When you say dependent science, what do you mean by that?
Another aspect, aside from the over-specialization, is that a lot of scientific research, almost all of it is, most people are relying on they go and get a university affiliation, and then they try and rely on research grants for very specific projects that have like a 3 to 5 year time scale, and it's, to me, if you know exactly what you're going to be studying 3 years from now, then you're not really looking at deep research questions. That's in my opinion. I know a lot of people that do good work in that, but for me, I think I'm interested in subjects where I don't know what I will have discovered 3 years from now. So myself and my father, after I left university, we started doing independent research, and then about I would say like 2009, I mentioned that we started becoming very interested in the climate change subject. And so we started looking into what people know about climate change, why people are concerned about it, and what are the theories involved and what's the data saying. And we did this all from in our own spare time. And we worked on that for a number of years, like in 2014. We all did it in our spare time, in our private, so completely independently of anything, just out of curiosity and see where it goes. And then in 2014, we launched all of our findings on published it on a couple of websites. And then we started communicating with the scientific communities. Some of the scientists started discussing it with us as well. So we started working with some scientists from around the world. And then in 2018, myself and a couple of colleagues decided we should set up a group specifically to continue with this independent research without having to rely on specific research grants and everything else. So we set up a group called Centre for Environmental Research and Earth Science, and we rely on donations from the public, but the donations can't influence, our donors can't influence our research direction or our findings. They just are encouraging us to keep doing what we're doing wherever that goes. And so it's still fairly small, but we're getting more and more interest over time. And if any of your viewers are interested in donating, it would be great. Go to ceres-science.com and there's a donate button there, and you can help what we're doing. So.
Excellent. So you are kind of like a general doctor, so to speak, like instead of like being a special doctor, you like the general like overview of topics.
Yeah, so there's this kind of two extreme things, you know. When people are studying, you know, this, should you specialize or should you be a specialist or a generalist? Problem. So the two extremes, you can learn more and more about less and less until eventually you know everything there is to know about nothing at all. Or if you go the other extreme, you could know less and less about more and more until eventually you know nothing about everything. And neither of those extremes work. So what I've taken, my approach has been to, you need to develop some sort of mastery about each of the topics before you can actually comment on it publicly, you know. So there's a research, you learn, try and master a subject, and then try and see how you're doing, share your results with others in the community, and once you've mastered one topic, you can then, it's a lot quicker to master a second topic. And I don't mean my master, I don't mean you know everything there is. That's what you quickly learn. You don't know everything there is, but you know enough to be able to contribute to others in the field. So that's it. But yes, I would say multidisciplinary scientist.
And that's especially true with the climate system, where it's spent through so many scientific fields. So you can't know it all just to be one field. You need to look at the big picture to understand it truly.
Yes, I totally agree. Like climate change is one obvious example where it involves geography, history, geology, chemistry, physics, computer modeling. There's like loads. You can have like there's dozens and dozens of relevant disciplines that have insights for looking at climate change and as a subject. And so it's important to have a bit of an overview of many of them in order to get a more holistic picture of what you're looking at.
Is that your opinion, or you are when you kind of like new in the science climate science community? Is that your point, like that the one who look at the sun not really care about what's going on in the ocean, and the one who cares about the ocean not really care about what's going on the sun, and vice versa?
Yes, though I wouldn't use the word "don't really care." It's because that sounds like they're being dismissive. It's more rather that people, understandably, are focusing on their own expertise, their own specialty, and it's not that they're saying these other bits are irrelevant. It's just that they're just focusing on the one bit that they know. The problem is when you're dealing with a multifaceted system, that won't you could be missing a lot of key information.
You need someone to connect the dots, so to speak.
Yeah.
In 2020, you released a study where you try to estimate the human-caused global warming if we continue as we do now. Can you try to tell me a little bit more about that study?
Yes, okay. That was published in the journal Energies. That paper. What we did is this was actually prompted by discussions with one of the co-authors on that paper. We had discussions with him back in 2015. This is the late Professor Bob Carter, Robert Carter, and he had been he was going to attend the Paris talks. I don't know if you recall in 2015 one of the one of the COP meetings. So these are the UN organized these Conference of the Parties meetings every year. So we were having this discussion about how could we actually you had all of these international negotiations saying we need to reduce emissions to save the climate, and it's like a very nebulous. What does that mean? How much how should you be reducing? How much is needed? What are we talking of exactly? Can we try and pin down the numbers? So the UN Conference of the Parties, and maybe we can talk about this in detail later if necessary, but the since the mid-90s, the UN EP has been assuming that climate change, the main driver of climate change, are increasing greenhouse gases. CO2 is the one they consider the main one. And so the COP meetings are specifically to try and get international negotiations to reduce the increase of these emissions. Now the gases that they're concerned about happen to be byproducts of pretty much a lot of the things that have allowed the world to go from being pre-industrial to industrial, allowed the population of the world to increase from 1.5 billion to touching on 8 billion today, has allowed developing economies to become developed. So there's a lot of different factors in there, and this is true mainly through the use of fossil fuels, and that's led to, as a byproduct, the increase of the carbon dioxide, CO2, atmospheric CO2, from pre-industrial, because this was a naturally occurring gas. Pre-industrial, it was they reckon about 0.03%, and now it's above 0.04%. And according to the climate models, computer models used by the UN, that's the main driver of climate change. So we can get into are those models correct or not. But we were looking at specifically assuming that the greenhouse gases are the main driver of climate change, whether you agree with it or not. So we decided to do this study to actually just say what would happen if we just continued business as usual. And we're not saying whether you should or not, but just to see what would happen as a baseline, and then you can make an assessment about how much you should change your approach relative to that. In 2020, what we did is we said, let's look at past increases in concentrations, atmospheric concentrations of the 3 greenhouse gases that the UN is most concerned about, which is carbon dioxide, methane, and N2O, or sorry, NO2. Yeah. So they we looked at them, and then we tried to extrapolate forward the concentrations, and then we compared that to the projections that the UN IPCC reports were used, and the community contributing to these reports were using. And it turns out that our business as usual was kind of a straight line with increasing error bars. They have a whole range of complex scenarios of future projections. So for the 5th assessment report, the IPCC is quite an important thing. I'd say some of your a lot of your viewers would be familiar with it, but if you're not, it's the Intergovernmental Panel on Climate Change, and they publish our IPCC. They publish these reports every 5 to 6 years, and we're on the 6th assessment report now. The previous one in 2013 and 2014 was the 5th assessment report. For the 5th assessment report, they had what are called the RCP scenarios of future growth of emissions, and they came up with 4. So there was RCP 8.5, or RCP 6.0, RCP 5 or 4.5, 2.6, and people didn't really know how relevant these were, and they just were picking the ones that suited. So our business as usual is kind of doesn't match up with any of them, but it kind of goes in between the 8.5 and the 6.0. And then for the 6th assessment report, they came up with SSP, or socioeconomic, it's SSP RCP. So they combine those RCP things with other scenarios. So they now have like nearly a dozen different scenarios of what would happen. And none of them are business as usual. And they're explicitly, if you look at the detail, they say, oh, these are just ideas of what might happen in the future. So that was the first thing. We just said, well, this is business as usual. And the business as usual happens to be below a lot of the scenarios that the IPCC is projecting. So and above some of the ones where they have reductions. So that's the first problem. How will the emissions change business as usual? And then the next thing is, what difference will that make to the climate? And this then comes to another problem, which I guess we probably should talk about. It's important to know. It's a topic called the climate sensitivity. And so there's a lot of different definitions, but the basic definition is that it's the amount of global warming that you would expect to occur from a doubling of CO2, atmospheric CO2, or CO2 equivalents. So you can convert methane into CO2 units, and that thing. And this should be like a key bit if you're trying to figure out, say, we need to urgently reduce this because it'll cause global warming, and you're like, how much global warming? And then it's like, well, that depends on the climate sensitivity. So in the 70s, some of the computer models, and in fact there was a report in 1979 by Jules Charney, led this US report, which is sometimes called the Charney report, and he looked and said the different computer models were projecting that the climate sensitivity was anywhere between 1.5 to 4.5 degrees Celsius for a doubling. So that's like a big difference, you know, because if you're like, say, let's just say 3 degrees was the global warming that you were concerned about. I'm not saying that, but just pick a value of 3 degrees. But if the climate sensitivity was 1.5 degrees, well, then you could quadruple CO2. But if the climate sensitivity was 6 degrees, then you could only increase it by 50%. That's correct. Or, you know, you can see it makes a big difference. So if you're saying how urgent it is, and so we said, well, to try and work out how much global warming you would expect under business as usual, assuming that greenhouse gases are the main driver of climate change, which the UN COP meetings are doing, we had to figure out, well, what is the range of climate sensitivity? And it turns out there are, I don't want to get too technical, but you can, if anyone's interested, you can read the paper, but there's 2 definitions of climate sensitivity that are in common use. One is called the equilibrium climate sensitivity, or ECS, and that's saying that what's the long-term increase in warming that would be expected over centuries from a given increase. And then there's what's called the transient climate response, or TCR. And so that is more the immediate. What would you, as the real-time increase in global temperatures that you would expect from a given increase in CO2. That's roughly what it is. And the IPCC, they had decided that this is in the 5th assessment report. I'll have to check. I did something similar for the 6th assessment report, but it hadn't been published at the time. But they said that the likely range of the equilibrium climate sensitivity was 1.5 to 4.5, as it the same as the Charney report, 1979. They were still saying it could be anywhere between those, and then they said that the transient climate response was likely between 1 degree Celsius and 2.5 degrees Celsius. So that's what. Let's just talk about the transient climate response, because it's a bit more real, more of the urgent metric. So what they're saying is, for doubling CO2, it's likely that the global warming you would expect could be 1 degree to 2.5 degrees. And they were explicitly saying, they used the term likely to say it could be higher or lower.
Yeah, they don't know.
And so what we then did is we took those likely estimates and we actually took a range. We took a range of different values of transient climate response and equilibrium climate sensitivity that were published by the literature, and we also highlighted the IPCC's estimates of likely ones. And then we said, what would you expect, how much global warming would you expect under business as usual for this climate sensitivity. And you can see, if you see, there's a graph in the papers, and you can see that there's a range of like warming at the bottom for the low climate sensitivities, the ones at the lower end of the IPCC's estimates and lower than IPCC, they predict a very gradual warming. And then the ones at the higher end predict a very rapid warming. And then what do I mean by that is that, okay, the Paris Agreement decided that we need to limit the arbitrarily, and there's some debate over these values, but they decided they needed a particular value of global warming that they wanted to minimize or to avoid. And they said 2 degrees relative to pre-industrial. And they also said, and we'd like to limit it to 1.5 degrees Celsius per relative to pre-industrial temperatures. And so what we showed is, if the climate sensitivity is at the bottom end of the IPCC's at the estimates, then if we could continue business as usual until the next century before the Paris Accord would have been broken. On the other hand, if it's at the higher end, well, then we've only another couple of decades, I think, depending on things, but by mid 21st century, we'd have broken it. And this is from the likely ranges of the IPCC. It's assuming what the IPCC is saying it. So they're saying the actual IPCC estimates of how sensitive the global temperatures are to greenhouse gases, when you plug them into a business as usual estimate, it says the Paris Accord could be broken under business as usual anytime between mid-century to next century.
So it's kind of like a guess. No, they don't really know. Just guessing.
But nonetheless, you have a lot of people that are promoting the IPCC or the UN saying it's urgent, and you will hear people taking these extreme scenarios and saying we are already close. We have to finish it by reduce emissions by 2030. By 20 every decade they keep on increasing when we need to have it done. So the UNEP, the head, before they set up the IPCC, I have a quote. I saw this article from 1989 from the head of the UNEP, and he was predicting that if we hadn't done things urgently by the year 2000, major cities all around the world would be under sea level. That was in 2000. And if you were to ask him, ask the UNEP, has society taken the types of major actions that he was calling for, they would say, no, we still need to do it. And it's 2022 now. And
people still buy property near the coastline. So they
there is a lot of hypocrisy, from some people that talk a Janus, like they talk out both sides of their mouth. But a lot of people genuinely believe what they're doing. But what I was saying is, we just needed to look at the whole thing. And again, tying back to this multidisciplinary, what we did there is we went across multiple fields in that analysis, because we're looking at theoretical physics approaches to assessing climate sensitivity, looking at model inputs, looking at the chemistry, looking at empirical data. So there's a lot of different fields. It's that's a long paper, and it's very detailed. And a lot of people, I know from experience that a lot of people have been intimidated by that particular paper because it's a very long one, and they look at it and say, but why are you talking about all of these each of these topics? You're looking at, I think, like 4 or 5 key scientific debates, and you're digging into each of them in detail, and I'm not familiar with these. And I'm like, so the point is, if you're not familiar with it, you should be, if you want to comment on it. So while it might look intimidating, I would encourage people to read the paper, not to take our word for it. We're reviewing the literature on it, but see the stuff, then follow up all of the literature. In that paper, we presented a whole range of people of views that are published in the literature.
Yeah, it's a 50 pages paper, so it takes a while to get through.
Yeah.
In that paper, you also talking about like the CO2 emission from humans. They also is bounded to the pre-industrial age, and it's kind of like debatable where that starts. In my mind, when you say pre-industrial age, is after World War II, where but there's a kind of like a mini definition of it, isn't it?
Oh yeah, no, definitely. And so what we did there, like we gave examples from the literature of people proposing a whole range of things. So there's like the one end, you have some people pointing at the 1940s, as you mentioned, as being the key, the main thing, particularly in terms of CO2 emissions and greenhouse gas emissions, because if you look at the emissions plots, there's a real dramatic uptick after World War II. But then there's others that are, the IPCC was originally saying 1850, another was 1880. Now for the 6th assessment report, some were arguing for 1750. I've seen there's like a guy, Professor Mark Maslin, and a few others are saying maybe we should look at 1492 when there was when Columbus started creating globalization of the eastern and western hemispheres. Then there is like Professor Bill Ruderman says that actually the anthropogenic, the human-caused influence on greenhouse gases, you can trace back to the agricultural, the rise of agricultural. So he's arguing that actually you should go back to the founding of civilization. So there's a whole range of different estimates. What we just said is we took rather than picking an end point, what we did is we said, looking at relative to the relative increase. So we didn't actually define the pre-industrial point, but what we do is the IPCC and many others, they use the Antarctic ice core estimates of past greenhouse gas concentrations to identify what the pre-industrial estimates were. And so we changed our things to the concentrations relative to those pre-industrial concentrations. So we kind of bypassed what year was pre-industrial for that analysis. And we said, defined the everything in terms of emissions or concentrations relative to the pre-industrial estimates. And I will put in the caveat, because we mentioned it in it, that there is debate in the literature over the reliability of those estimates from the Antarctic ice cores. And that's a whole can of worms that it's best not to get into here, but we do discuss it in the paper. So if people are interested in looking up on that, they can see some different views on that.
So in your point of view, like the conclusion, what you see that the business as usual, would that cause a problem? In your mind?
Well, you see, a lot of it depends on the climate sensitivity. So I have my own views on it. That we can get into that. I've talked about it, but if you take the IPCC's estimates of the climate sensitivity and you take the lower bound and you believe that CO2 and greenhouse gases are the main driver of climate, well then they say that 2 degrees relative to pre-industrial, 2 degrees of human-caused global warming is, we have to keep below that, and ideally 1.5. So if you take the lower estimates of the climate sensitivity that the IPCC says is likely, then not urgent for, it's like next century, it's a problem for the 22nd century. You know, and so you could then say, if you believe that, then clearly, if you are concerned about doing that, we shouldn't just be saying, oh, let's just kick it down for a century, because then in the 22nd century, you could do it. But a lot of people would say, well, you should still try and transition over the next century. But that's a completely different urgency than in the next few decades, right? If it's at the upper end, well then, you know, the of the IPCC's likely end, then it's hard to see that anything that's been done would really make a whole lot of difference. But you know, so it comes down to the business as usual. How bad is it? It depends on fundamentally what is the climate how influenced are global temperatures on greenhouse gas concentrations.
And also at what cost? What cost do you do for civilization for reducing emission a bit?
You can get into a lot of economic analysis, and you know, I think there's controversially one of your fellow Danes, Bjorn Lomborg, has written extensively about his efforts to try and quantify the economic policies. To a lot of he's one of those figures that is loved and hated by different people, depending on whether they agree with what he's finding or not, largely.
But that's an important side of the coin to estimate. Like maybe you lower this CO2, but what harm does it do? Is it worse than a little bit more CO2 in the atmosphere?
Yes, and one of the there's a there is a nice quote by, this was like an American humorist, like a writer, I think he wrote for the Reader's Digest or something like that, Andrew Glaso, I think is, and he said, the fewer the facts, the stronger the opinion. And I think that that's a very important, very helpful thing to bear in mind, because I just explained how even using the uncertainty that the IPCC is saying about the climate sensitivity, you could get business as usual being a problem for the next century versus a problem over the next few decades.
Dr. Ronan Connelly, I will thank you for doing this. I appreciate it.
Thank you for inviting me.